This is a recording for section 12.3, measures of dispersion. So in 12.2, we talked about the measures of center, so the mean, median, and mode. So not only are we often interested in just what is the average, but we want to know how spread apart the data values are, because two very different data sets can have the same average. The first measure of dispersion that we're going to look at is the range. It's used to describe the spread of the data. The two most common measures of dispersion are range and standard deviation. The range is just the difference between the highest and lowest data value. So for example, down here, Honolulu's hottest day is 89 degrees and its coldest day is 61 degrees. Find the range in temperature. So the range is just you take the highest data value minus the lowest data value, and it looks like that will be 28 degrees. Find the range of the following data sets. Compare the two and discuss the spread of the data set. So if we look at the first data set, it looks like the high is 40 and the low is 3. So if we do 40 minus 3, the range is 37 for the first data set. And over here in the second data set, looks like the high is 80 and the low is 44. So for the second data set, that should give you 36 for the range. So you can see that the range is very close. So the range says discuss the spread. The range of these sets is nearly the same. That's supposed to be nearly, although it doesn't look like it. Nearly the same. But if you look at the spread of the data, they're very different. Like all of these are sort of clustered around single digits, and then you have this 40, right? Whereas these are much more close together, right? But the spread is very different. So what we really want is to determine a good measure of spread, which is called the standard deviation. The standard deviation represents, on average, how far the data values are from the mean. Which data set do you think has a larger standard deviation and why? Well, if you look at these data values are close together. All right, 45 to 49. These data values, they have a few of them that are close together, but these are more spread out because we have this 31. So data set B should have the larger standard deviation. Okay. So the larger the standard deviation, the higher the average is from each data value from the mean, right? So the more spread apart they are. So the standard deviation, in order to compute it by hand, it's a several step process. The first thing is that you are required to find the mean, right? We find the mean by adding up the number of data values and dividing by the total number of data values. Then you're going to take each data value from the mean and you're going to square it. So it doesn't matter if you do mean minus data value or data value minus mean. It doesn't matter if it ends up being positive or negative because you're going to square them. All right, so you're going to take the data value minus the mean. You're going to square them. You're going to have to know this process for the test. Then you're going to add all these up. And next you will divide by n minus 1, and n is always the number of data values. So if you have 5 data values, you're going to divide this sum by 4. Right? So remember, the mean you divide by n, but when you're computing the standard deviation, you're going to divide by n minus 1. And the very last step is to take the square root of this. Okay. So find the standard deviation of age of the 5 oldest U.S. presidents at inauguration, round to the nearest hundredth. So we are going to follow the steps. Our data values are, it looks like 69, 68, 65, 64, and 64. All right. So the first step, you can look back on the last slide for the steps. The first step is to find the mean. So the mean is we're going to add up these 5 data values and divide by 5. And remember, do not round in intermediate steps. So if the mean, you should care, if it doesn't terminate, this one will terminate because it's dividing by 5. But if you had something that didn't terminate, you should keep a lot of decimal places. 69 plus 68 plus 65 plus 64 plus 64, and then be sure to hit enter. So this is 330 divided by 5. Leave yourself plenty of space, is 66. So this mean actually for this one is a nice whole number, 66. So what I would suggest doing for step 2 is subtract each data value from the mean, and then step 3 is square it. So I'm going to do step 2 and 3 together. So we're going to take each data value, we're going to subtract the mean, and then we are going to square it. Okay. So each of our data values, so 69, and our mean is 66, so that's going to stay the same. 69 minus 66 squared. I'm going to go ahead and write them out first, and then I'll go ahead and compute them. 68 minus 66 squared. 65 minus 66 squared. 64 minus 66 squared. 64 minus 66 squared. All right, and 69 minus 66 is 3 squared, which is 9. 2 squared, which is 4. 65 minus 66 is -1, but you're going to square it anyway, which becomes 1. All right, squared just means times itself. -1 times -1 is +1. 64 minus 66 is -2 squared, which is +4. Watch it if you decide to punch that in on the calculator, because you would have to put -2 in parentheses. Any of these squared should always be positive. These will always end up positive. If you don't put the parentheses in the calculator, it will come up to be negative, which you know is not right. Okay, so step 2 and 3. So step 2 is take the data value, subtract the mean. Step 3 is to square those results, which we already did. So we did those steps together. Step 4 is to add these up. All right, 9 plus 4 plus 1 plus 4 plus 4, that's 12. 13 plus 9 is 22. If you look back at the previous slide, step 4 was add these up. Step 5 is to divide by n minus 1, and n is 5. All right, n is always the number of data values, which is 5. So we're going to take our 22 and we're going to divide it by 5 minus 1. So it's 22 divided by 4. And if that doesn't terminate, you should keep all the decimal places, but it does. If you hit 22 divided by 4, it is 5.5. But if it doesn't, you need to keep all the decimal places. And our last step, our step 6, was to take the square root of that. You can look at the last slide is to take the square root, and so we want the square root of 5.5. And square root is there on the TI-30X11S. It's 1, 2, 3, 4, 5. It's 6 buttons down on the left, but you have to hit the second function button first, the blue one in the upper left-hand corner, or whatever color yours might be. The upper left-hand corner, second function, x squared, which will give you the square root, 5.5, and be sure to close the parentheses, and you should get, and it says round to the nearest hundredth, so you should get it's 2.345, so you should get 2.35 as a standard deviation. So again, it's a 6-step process. If you will just need to memorize those steps. Find the mean, data value minus mean, square it, divide by n minus 1, or add those up, divide by n minus 1, and take the square root. So what this means, it means on average, the ages are 2.35 years away from the mean age of, what was the mean age? The mean age was 66. So some of the ages will be older, right? It means 2.35 away means either 2.535 below the mean of 66 or above. You can see that some of them are above and some of them are below the mean, but they are on average 2.35 years away from the mean. After recording the pizza delivery times for 2 different pizza shops, you conclude that one pizza shop has a mean delivery time of 45 minutes with a standard deviation of 3 minutes. The other shop has a mean delivery time of 41 minutes, a standard deviation of 20 minutes. Interpret these figures. If you like the pizza from both shops equally well, which one would you order from and why? Well, the first one has a mean of 45 minutes and a standard deviation of 3 minutes. The other is 41 minutes with a standard deviation of 20 minutes. So even though this is lower average time, the standard deviation is large, right? Which it means it varies so significantly in delivery time. So it could actually be closer to 61 minutes before we get it, the pizza, right? So I would deliver from the first pizza shop where the mean is 45 because it's more consistent. All right, if the standard deviation is 3 minutes, you can really expect it to be in that interval from, if 45 is the mean and the standard deviation is 3 minutes, you can probably really expect it to be, in this range from 42 to 48 minutes.